Rechlin-Lerche Airfield, Germany. The morning of July 23, 1943, Oberst Hans-Werner Lerche, the Luftwaffe's chief test pilot, stood in the briefing room staring at a tactical map of Western Europe. Red pins marked recent Allied bomber raids. There were dozens of them, scattered across the Ruhr, across northern France, across Bremen and Hamburg. Each pin represented hundreds of bombers, mostly B-17 flying fortresses. His commanding officer had given him a simple assignment that morning. Fly the captured B-17 that had arrived 3 weeks earlier, not just a ground inspection, a full evaluation flight. Take it up, push it through combat maneuvers, understand what German fighter pilots were facing, and most importantly, understand why Luftwaffe losses were climbing, while American bomber formations kept growing larger. Within 60 minutes of takeoff, Lerche would radio the control tower with a request that surprised everyone listening. He wanted to stay airborne longer, much longer, because he'd discovered something that changed his entire understanding of aerial warfare. The B-17 wasn't just a bomber, it was a flying fortress in the most literal sense, a weapons platform so heavily armed that traditional fighter tactics were becoming obsolete. And if the Americans could mass-produce these aircraft faster than Germany could shoot them down, the mathematics of the air war had already been decided. Lerche would land that afternoon and write a report so technically precise and strategically devastating that it would be classified immediately. His conclusion would be filed, disputed, and ultimately ignored by Luftwaffe High Command. But his assessment would prove correct. The era of the unescorted bomber was supposed to be a fantasy, a failure, a lesson written in blood over Germany's skies, except the Americans had built something that came dangerously close to making that fantasy real, and when long-range fighter escorts finally arrived months later, the combination would prove unstoppable. This is the story of one test flight that revealed a fundamental shift in aerial warfare, a shift that German leadership refused to accept until it was far too late. Hans-Werner Lerche was not a typical Luftwaffe officer. Born in 1916 in Breslau, he'd grown up during the chaotic years of the Weimar Republic when Germany was forbidden from having military aircraft. Young Germans who wanted to fly joined glider clubs, and Lerche was one of thousands who spent weekends on hillsides launching sailplanes into the wind. By the time Hitler came to power and began Germany's secret rearmament, Lerche had logged hundreds of hours in unpowered flight. He understood aerodynamics intuitively. When the Luftwaffe was officially established in 1935, opportunities opened for skilled pilots. Lerche joined immediately, but rather than pursuing a combat role, he gravitated toward testing. By 1939, he was stationed at Rechlin, the Luftwaffe's primary aircraft testing facility. This was Germany's equivalent to America's Wright Field or Britain's Farnborough. Every new German aircraft design came through Rechlin. Every captured enemy aircraft ended up there for evaluation. Lerche flew everything. The latest German prototypes, production variants with modified systems, British Spitfires and Hurricanes, Soviet fighters, and increasingly American aircraft. His logbook would eventually document more than 120 different aircraft types. He held a degree in aeronautical engineering, and his reports were known throughout the Luftwaffe for their brutal honesty. When a German aircraft had flaws, he documented them precisely. When an enemy aircraft was superior, he said so clearly. This honesty had earned him respect among engineers and pilots, but it had also made him enemies among Nazi Party officials who preferred optimistic assessments to uncomfortable truths. By mid-1943, as Germany's military situation deteriorated, being the bearer of bad news was becoming increasingly dangerous. Men who pointed out strategic problems were sometimes accused of defeatism. But Lerche's expertise was too valuable to dismiss. If he said an aircraft was dangerous, people listened. The B-17 Flying Fortress, sitting on the Rechlin tarmac in July 1943, had arrived under unusual circumstances. Its pilot, Second Lieutenant Robert Cahow of the 91st Bomb Group, had been flying a mission over northern Germany when his aircraft took heavy flak damage. The number 4 engine was destroyed, the number 3 engine was losing oil pressure, and the hydraulic system was partially disabled. Separated from his formation and losing altitude, Cahow had 2 choices: bail out his crew over Germany, where they'd become prisoners of war, or try to reach neutral territory. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He chose Sweden. It was a gamble. Sweden was neutral, and aircraft that landed there would be interned rather than captured. The crew would sit out the war in comfortable internment rather than in prisoner-of-war camps. But Sweden was hundreds of miles away, and he had two failing engines. Kahau nursed the damaged bomber northward, watching his altitude bleed away. He didn't make it to Sweden. He made it to Denmark, still German-occupied territory. He put the B-17 down in a field near the coast, executing a wheels-up belly landing that destroyed the aircraft's underside but left the rest intact. The crew was captured immediately, but the bomber itself was a prize. The Luftwaffe had examined crashed B-17s before, but this one was relatively undamaged. The fuselage was intact, 3 engines were still functional, the armament was complete. German engineers swarmed over it, taking measurements, photographing components, documenting everything. Then they carefully disassembled it, transported it to Rechlin, and rebuilt it. By early July, it was airworthy again. Lerche had read the preliminary engineering reports. He'd examined wrecked B-17 components before, but this would be his first flight in a complete, operational heavy bomber. He knew the basic specifications. 4 Wright R-1820 Cyclone radial engines, each producing 1,200 horsepower, empty weight around 32,000 pounds, maximum takeoff weight 65,000 pounds, wingspan 103 feet, length 74 feet, height 19 feet at the tail, service ceiling around 35,000 feet, maximum speed approximately 290 miles per hour, range with standard bomb load around 2,000 miles, but specifications on paper told him nothing about how the aircraft actually performed in combat. That's what this test flight was for. The morning of July 23rd was clear. Good visibility, light winds, perfect conditions for a comprehensive evaluation. Lerche walked across the tarmac toward the B-17. It had been repainted in German camouflage with Luftwaffe markings, but the basic olive drab American paint still showed through in places. The aircraft looked enormous compared to German bombers like the Heinkel He 111 or Junkers Ju-88. Even compared to the largest German aircraft, the 4-engine Focke-Wulf FW-200 Condor, the B-17 seemed massive and brutal. German bombers had a certain aesthetic elegance, sleek lines, carefully streamlined nacelles, attention to aerodynamic efficiency. The B-17 looked like it had been designed by someone who didn't care about elegance. The fuselage was thick and slab-sided. The radial engines protruded from the wings in bulky nacelles. The tail was enormous, towering 3 stories high. Everything about it screamed brute force over finesse. But as Lerche approached, he noticed something else. The construction quality was exceptional. The panel gaps were tight and even. The metal skin was smooth and precisely formed. The engine cowlings fit perfectly. This wasn't crude manufacturing. This was high-quality mass production, and there was a profound difference. Germany could build excellent aircraft in small numbers. America was apparently building excellent aircraft in vast numbers. Lerche climbed aboard through the rear entry hatch. The interior was cramped, utilitarian, every inch dedicated to function. He made his way forward through the fuselage, past the radio operator's position, past the bomb bay with its empty racks, forward to the flight deck. The cockpit was spacious by German standards, with side-by-side seating for pilot and co-pilot. Visibility was excellent, with large windows wrapping around the front and sides, but what immediately caught Lerche's attention was the defensive armament, and it was everywhere. The B-17F model that Lerche was about to fly carried 13 50 caliber Browning M2 machine guns. 13. He stood there, mentally cataloguing them. 2 in the nose, operated manually by the bombardier and navigator. 2 in the top turret, a powered Sperry ball turret that could rotate 360 degrees. 2 in the ball turret underneath the fuselage, perhaps the most claustrophobic and dangerous position on the aircraft. 2 at the waist positions, 1 on each side. two in the tail, covering rear approaches, one in the radio compartment, firing upward through a hatch. For comparison, the standard German medium bomber, the He-111, carried 3 to 5 machine guns for defense, typically 7.92mm rifle-caliber weapons. The Ju-88 carried about the same. The B-17 had 13 heavy machine guns. The 50-caliber Browning was not a rifle-caliber weapon. It was originally designed as an anti-vehicle and anti-aircraft gun. Each round was 12.7mm in diameter, weighing about 1.5 ounces, fired at approximately 2,900 feet per second. When 13 of these guns fired simultaneously, the B-17 could throw out over 100 rounds per second. Lerche examined the ammunition storage. Each gun had approximately 400 rounds, though the numbers varied by position. Total ammunition, over 3,000 rounds of 50 caliber. The belt feeds were sophisticated. The ammunition was stored efficiently throughout the aircraft to maintain proper weight distribution. Someone had thought very carefully about how to turn this bomber into a weapons platform. He climbed into the pilot's seat. The cockpit layout was logical and well organized. Flight controls were conventional, throttles on the left side, instrument panel directly ahead. But here was something interesting. The instruments used color coding. Green sections marked acceptable operating ranges. Red sections marked danger zones. A pilot could monitor engine status at a glance without having to read precise numbers. German instruments required exact understanding of specifications. The American instruments were designed to be intuitive. Lerche went through the pre-flight checklist with a German flight engineer who'd been studying the aircraft for weeks. They started the engines one at a time. Each right cyclone radial coughed, sputtered, and then settled into a smooth, powerful rumble. Lerche noted the vibration characteristics. Radial engines inherently produced more vibration than inline engines, but these felt smooth and controlled. No concerning rattles, no irregular firing, just solid mechanical operation. He taxied toward the runway. The B-17's landing gear was wide and robust, the tail wheel locked into position, tracking straight. Ground handling was straightforward. Visibility over the nose was adequate. The aircraft felt stable. In a German bomber, especially the Ju-88 with its relatively narrow landing gear, taxiing required constant attention. The B-17 felt forgiving, almost docile. Lerche lined up on the runway, ran through the final checks, and advanced the throttles. 4 1,200 horsepower engines responded immediately. The acceleration was surprisingly brisk for such a heavy aircraft. The takeoff run was long by German standards, but not excessive. The B-17 lifted off smoothly, and Lerche retracted the landing gear. He established a climb and headed toward the designated test area, a section of airspace over eastern Germany where he could fly freely without risk of encountering Allied aircraft. During the climb to altitude, Lerche tested basic handling. The controls were heavy but responsive. The B-17 wasn't agile, it didn't need to be, but it was stable and predictable. There were no unexpected behaviors, no quirks that required careful management. Everything functioned exactly as designed. At 10,000 feet, Lerche leveled off temporarily and began his systematic evaluation. He tested turn performance. As expected, the B-17 turned slowly, requiring large amounts of airspace to complete even a gentle turn. But the turn was coordinated and smooth. He tested climb performance at various power settings. The climb rate was adequate, but not impressive. This was not an aircraft designed to climb rapidly. Then he climbed to 25,000 feet, and everything changed. At high altitude, the B-17 came into its element. The turbo-supercharged engines maintained power where naturally aspirated engines would be gasping. German bombers typically operated at 15,000 to 20,000 feet. Above that, engine performance dropped dramatically. The B-17 cruised comfortably at 25,000 feet and could operate up to 35,000 feet. This altitude advantage was strategically crucial. German fighters were optimized for lower altitude performance. The Messerschmitt Bf-109 could reach 25,000 feet, but it took time and fuel, and performance at that altitude was marginal. The Focke-Wulf FW-190 was worse, really struggling above 20,000 feet. The B-17 operated in a region where German fighters were at a severe disadvantage. But altitude advantage was only part of the equation. Lerche knew from intelligence reports and pilot debriefs that B-17s were difficult to shoot down. He'd read the accounts. German fighters would attack, score hits with 20mm cannon fire, and watch the bomber continue flying. Some B-17s returned to England with catastrophic damage, entire sections of the fuselage blown away, engines destroyed, yet still flying. The aircraft seemed absurdly survivable. Now, sitting in the pilot's seat at 25,000 feet, Lerche decided to understand why. He radioed Rechlin Control Tower and requested permission to extend the test flight. Approved. He had fuel for several more hours. He began examining the defensive fire arcs. This required mental simulation, since he was alone in the aircraft, but Lerche had studied the gun positions during his pre-flight inspection. He now visualized how they'd function. In combat, from the pilot's seat, he couldn't actually see most of the defensive guns. They were operated by specialized gunners throughout the aircraft, but he could imagine an attacking fighter's perspective. Consider a Bf-109 making a frontal attack. This was standard Luftwaffe doctrine. The nose guns on early B-17 models were the weakest point, just 2 handheld machine guns. But even those 2 guns, 50 caliber weapons, could destroy a fighter with a lucky hit, and the fighter, closing from the front, was exposed to fire not just from the nose guns, but also from the top turret if it could depress low enough, and potentially from the cheek guns if the B-17F had them installed. The closing speed in a head-on attack was extreme. The B-17 cruising at 200 miles per hour, the fighter approaching at 300 miles per hour. Combined closure rate, 500 miles per hour. That meant the fighter had perhaps 2 seconds of firing time before having to break away or risk collision. 2 seconds to aim, fire, and hit a specific target on the bomber while the bomber's guns fired back. And if the fighter pilot flinched, if he broke away even a fraction of a second early, his attack would be ineffective. Now, consider an attack from behind, the classic tail chase. The B-17's tail gun position had 2 50 caliber guns with excellent visibility and fields of fire. A fighter pilot approaching from dead astern would fly directly into sustained fire from 2 heavy machine guns. The tail gunner, sitting in his isolated position, had one job: protect the rear. He'd be watching constantly, ready to fire the instant a fighter appeared. German fighter pilots reported that B-17 tail gunners were accurate and aggressive. The smart ones didn't attack from dead astern. They attacked from below and behind, where the tail guns had limited depression, but that exposed them to the ball turret, a powered Sperry turret that could rotate to aim in nearly any direction below the aircraft. The ball turret gunner sat in a cramped plexiglass sphere, suspended beneath the fuselage, surrounded by his guns and ammunition, arguably the most vulnerable and uncomfortable position on the aircraft. But he had excellent visibility below and could track targets with precision. Attacks from above. The top turret covered the upper hemisphere. 2 50 caliber guns in a powered turret with fast traverse. Attacks from the sides. The waist gunners, 1 on each side, with overlapping fields of fire. Lerche worked through every possible attack angle in his mind. Every approach had defensive coverage. Some positions were weaker than others, certainly, but there was no blind spot, no angle from which a fighter could attack without facing return fire. And here was the crucial realization. A B-17 didn't fly alone. American bomber doctrine emphasized tight formations. A standard combat box formation might include 18 to 21 bombers in a compact group. Multiple combat boxes would form a larger formation, sometimes 50 to 100 bombers in a single massive formation. When bombers flew in tight formation, their defensive fire overlapped. A fighter attacking one bomber would be exposed to fire from multiple aircraft. The gunners were trained to support each other, to mass their fire on attacking fighters. Intelligence reports indicated that American bomber crews practiced formation flying and defensive tactics extensively. They'd developed a system where the bombers protected each other. Lerche had studied the reports from German fighter squadrons. The accounts were consistent and troubling. Fighters would press an attack, score hits, and then break away damaged or destroyed by defensive fire. The loss rates among German fighter pilots were climbing. In the early months of the American bombing campaign, when formations were small and German fighters could attack aggressively, the bombers suffered terribly. But as the Americans refined their tactics, tightened their formations, and improved their defensive coordination, the equation changed. By mid-1943, attacking a B-17 formation was extraordinarily dangerous. Pilots described walls of tracers, interlocking fire from dozens of guns. The psychological impact was enormous. Flying directly toward a formation of bombers, knowing that hundreds of gun barrels were pointed at you, required tremendous courage. Many pilots hesitated, broke off attacks early, or fired from too far away to be effective. Now, Lerche understood why. He was sitting inside a weapons platform that could defend itself, not perfectly, not without losses, but effectively enough that attacking it carried unacceptable risks. And if the Americans could build enough of these aircraft, if they could maintain their formations and keep bombing day after day, German fighters would be ground down through attrition. He continued his test flight, running through more maneuvers. He tested dive performance, accelerating downward to see how the aircraft handled at high speed. The B-17 accelerated smoothly and remained controllable. He tested recovery from the dive, pulling back on the yoke. The aircraft responded predictably, the massive wings generating tremendous lift. He tested engine-out procedures, throttling back one engine to simulate battle damage. The B-17 flew acceptably on 3 engines. He throttled back a second engine. On 2 engines, the aircraft could maintain altitude, but not climb. This was critical information. A B-17 could lose 2 engines and still potentially make it home. German bombers couldn't do that. Lose 1 engine on a Ju-88, and you had serious problems. Lose both, and you were going down immediately. The B-17's 4-engine layout provided redundancy that made it far more survivable. Lerche flew for nearly 90 minutes, collecting data, making observations, understanding the aircraft's capabilities. Finally, low on fuel, he returned to Rechlin and landed. The landing was straightforward. The robust landing gear absorbed the touchdown firmly. He taxied back to the hangar and shut down the engines. Ground crew and engineers gathered around, eager for his assessment. What had he discovered? What were the aircraft's vulnerabilities? How should German fighters attack it? Lerche climbed out slowly, his mind already organizing the report he'd need to write. He stood, looking at the B-17 for a long moment. Someone asked him directly, "Can our fighters defeat these bombers?" Lerche chose his words carefully. "Not the way we're currently attacking them. The defensive armament is far more effective than intelligence reports suggested. This aircraft was designed specifically to survive fighter attacks through overwhelming defensive firepower." "But they're still bombers," one of the engineers said. "Bombers aren't supposed to be able to defend themselves." "This one can," Lerche replied, "or nearly can. American bomber doctrine assumes heavy losses, but they've designed an aircraft that can reduce those losses to acceptable levels, and if they mass these aircraft in large formations with overlapping defensive fire, attacking them becomes suicidal." The implications hung in the air. If American bombers could defend themselves effectively, if attacking them meant unacceptable German fighter losses, then what? The answer was obvious but unspoken. Germany needed its own long-range fighters to escort bombers deep into enemy territory. But Germany didn't have such fighters. The Bf-109 had limited range. The Fw-190 was even worse. Germany's strategic situation was built around defensive fighting over its own territory, not long-range escort missions. Meanwhile, America was developing long-range fighters. Intelligence reports mentioned the P-51 Mustang, a new American fighter with extraordinary range. If B-17s could already defend themselves reasonably well, and if long-range American fighters arrived to escort them, German fighters would face an impossible situation. That evening, Lerche sat at his desk and began writing his comprehensive technical report. He organized it methodically, the way he always did. Performance characteristics, handling qualities, systems evaluation, and finally, strategic assessment. The first sections were straightforward. The B-17 was fast for a heavy bomber, stable in flight, capable of operating at high altitude where German fighters struggled. Its engines were reliable and powerful. Its systems were well designed and functional. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. But it was in the defensive armament section that Lerche wrote something that would prove both accurate and controversial. The B-17 Flying Fortress carries 1350 caliber machine guns in positions covering all approach angles. When operating in tight formation, multiple aircraft create overlapping fields of fire that make conventional fighter attacks extremely hazardous. The defensive firepower is sufficient that the bomber can operate with reduced fighter escort or potentially without escort over short to medium distances. He paused, considering that last phrase. Was it accurate? Could B-17s really operate without escorts? The Americans were certainly trying. Their early raids over German-occupied Europe had been flown without fighter escort because no Allied fighter had sufficient range. The results had been mixed. Some raids succeeded with acceptable losses. Other raids, particularly those that penetrated deep into Germany, suffered catastrophic casualties. The raid on Schweinfurt in August would prove this point. Without fighter escort for the final leg of the mission, 60 B-17s would be shot down out of 230 aircraft, a 26% loss rate. Unsustainable. But that was still in the future. As Lerche wrote his report in July 1943, the question remained open. Could heavy defensive armament substitute for fighter escorts? His honest answer was nuanced. The B-17's defensive armament significantly reduces its vulnerability to fighter attacks, but does not eliminate it. Operating without escort remains risky, particularly against concentrated German fighter defenses. However, the defensive capability is sufficient that when long-range escort fighters become available, the combination will be devastating. German fighters will face the choice of engaging well-defended bombers or well-armed escort fighters. Either option carries high risk. In his strategic assessment section, Lerche addressed the production question. How many B-17s could America build? Intelligence estimates suggested Boeing was producing approximately 100 aircraft per month across multiple factories. Plans called for expanding production to 300 per month or more. Germany's entire heavy bomber production, all types combined, was approximately 50 aircraft per month and declining as factories were bombed and resources diverted to fighter production. America is building heavy bombers at rates Germany cannot match, Lerche wrote. Each B-17 represents significant resource investment, but America appears to have effectively unlimited resources. If they can sustain production and accept initial loss rates, they will achieve numerical superiority that makes defensive success impossible. He wrote about the quality issue. The captured B-17 showed no evidence of manufacturing shortcuts. The aluminum was high-grade, the components precisely machined, the assembly quality exceptional. This was sophisticated mass production. Germany was increasingly forced to use substitute materials and accept lower quality standards as the war strained industrial capacity. America showed no such constraints. Finally, Lerche addressed the question everyone wanted answered. How should German fighters attack B-17 formations? His recommendations were specific. Avoid frontal attacks unless absolutely necessary. Closing speeds are too high for accurate fire, and bomber defensive armament is effective. Avoid stern attacks. Tailgun positions are well designed and gunners are trained. Optimal attack angles are from above and ahead, diving through the formation at high speed to minimize exposure to defensive fire, or from below and behind, staying outside ball turret firing arcs when possible. However, he continued, all attack angles carry significant risk. Pilots must be highly skilled and accept that casualties will be high. The most effective tactic is to disrupt formations before they reach targets, forcing bombers to break formation where they lose mutual defensive support. But this requires numerical superiority and coordination that our fighter forces increasingly lack. He concluded with a sentence that he knew would be controversial. The B-17 Flying Fortress represents a fundamental challenge to German air superiority. We cannot prevent these aircraft from reaching targets through defensive action alone. We must destroy them on the ground, disrupt their production, or accept that strategic bombing of Germany will continue indefinitely. Lerche signed the report and submitted it through proper channels. He knew it would be read by Luftwaffe High Command, by intelligence analysts, by tactical planners. He wondered if anyone would take it seriously. His report arrived on desks throughout the Luftwaffe command structure over the following days. Some readers found it pessimistic, others found it unrealistic. The idea that bombers could defend themselves without fighter escort seemed absurd. Bombers were supposed to be vulnerable. That was the fundamental assumption of air warfare doctrine. Fighters attacked, bombers died. That's how it had always worked. But Lerche wasn't making a theoretical argument. He was reporting observed reality. The B-17 was extraordinarily well defended, and American tactics maximized that defensive capability. The numbers supported his conclusion. In early raids over France and the Netherlands, where German fighter resistance was moderate, B-17 losses were acceptable, typically under 5%. The Americans could sustain 5% losses indefinitely and still expand their bombing campaign. Only when raids penetrated deep into Germany, beyond fighter escort range, and into areas with concentrated Luftwaffe defenses, did losses spike to unsustainable levels. This suggested a clear conclusion. B-17s needed fighter escorts for deep penetration raids, but could operate independently over shorter ranges. The defensive armament wasn't making escorts obsolete, but it was reducing the escort requirement significantly. This distinction mattered enormously. If American bombers required constant fighter protection, Germany could potentially concentrate its fighters to overwhelm the escorts and then destroy the vulnerable bombers. But if bombers could operate with limited escort or no escort over parts of their mission, German fighters had to engage the heavily armed formations directly. That meant high German losses to achieve even moderate bomber losses. The mathematics were brutal. If shooting down one B-17 cost Germany 2 Bf-109 fighters, who won that exchange? America could replace both losses easily. Germany could not. The war of attrition favored the side with greater production capacity, and that wasn't Germany. Through August and September 1943, Lerche's predictions began coming true. American bombing raids continued to grow in size and frequency. Some raids were devastated by German fighters. The second Schweinfurt raid in October lost 60 bombers, forcing the Americans to temporarily halt deep penetration missions. But even these German victories came at a terrible cost. Fighter losses were mounting. Experienced pilots were being killed. The Luftwaffe was being bled. And then, in early 1944, everything changed. The P-51 Mustang arrived in numbers. This American fighter had been fitted with a British Rolls-Royce Merlin engine, transforming it into a superb high-altitude fighter with extraordinary range. P-51s could escort B-17 formations all the way to Berlin and back. Suddenly, German fighters faced exactly the situation Lerche had predicted. Attack well-defended bombers or fight off aggressive escort fighters. The result was catastrophic for the Luftwaffe. In the first months of 1944, German fighter losses exploded. In February alone, nearly 400 fighters were destroyed. In March, another 500. The Luftwaffe was losing not just aircraft, but irreplaceable pilots. Training programs couldn't keep up. New pilots arrived at frontline units with minimal experience and died within days or weeks. By D-Day in June 1944, the Luftwaffe had effectively lost air superiority over Western Europe. Allied bombers roamed at will. Fighter escorts destroyed German aircraft on the ground. The bombing campaign that had seemed so costly in 1943 now proceeded with acceptable losses, sometimes under 2% per mission. Lerche continued his work at Rechlin throughout this period. flying captured Allied aircraft and writing reports that grew increasingly pessimistic. He flew a captured P-51 and was impressed by its combination of speed, range, and handling. He wrote, "This aircraft represents exactly what Germany needs, but does not have. A long-range fighter capable of protecting bombers deep into enemy territory. The Americans have developed this capability. We have not." His reports were still filed, still read, still largely ignored, because by 1944, accurate intelligence couldn't change Germany's strategic situation. The industrial disparity was too great, the resource advantage too overwhelming. The Luftwaffe could fight skillfully, but it couldn't win a war of attrition against an enemy that could build aircraft faster than they could be destroyed. The captured B-17 that Lerche flew in July 1943 remained at Rechlin for several more months, used for additional testing and evaluation. Eventually, it was transferred to a special unit that operated captured Allied aircraft for covert missions and training purposes. Its ultimate fate is unclear, but likely it was destroyed in an Allied bombing raid or abandoned as Germany collapsed in 1945. Lieutenant Cahot, the pilot who had crash-landed the aircraft in Denmark, spent the rest of the war as a prisoner. He returned home to the United States in 1945, never knowing that his bomber had provided German test pilots with crucial intelligence about American capabilities, though, in a larger sense, it hadn't mattered. By the time Lerche flew the B-17, the outcome of the air war was already determined by factors far beyond any single aircraft evaluation. After Germany's surrender, Lerche was interrogated by Allied intelligence officers who were fascinated by his experiences flying captured aircraft. They asked specifically about his B-17 evaluation. Had he really concluded that the defensive armament could substitute for fighter escorts? Lerche's answer was careful and precise. "I concluded that the defensive armament was far more effective than German intelligence had estimated. I concluded that attacking B-17 formations would be costly, and I concluded that when long-range escorts became available, the combination would be unstoppable. All of these conclusions proved accurate." "Did Luftwaffe command act on your recommendations?" an American officer asked. Lerche smiled without humor. "They filed my report. Some tactical adjustments were made. Fighter pilots were briefed on optimal attack angles. But the fundamental problem couldn't be solved through tactics. You had more bombers than we had fighters, more production capacity than we could match, and eventually you developed escorts that could protect your bombers throughout their missions. No amount of tactical innovation could overcome that disparity." The interrogators showed him American production figures: over 12,700 B-17s built during the war, over 15,000 P-51 Mustangs, total American aircraft production exceeding 300,000 aircraft from 1940 to 1945. German production in the same period, approximately 94,000 aircraft. Lerche studied the numbers silently. Then he said something that summarized his entire experience. "I flew your B-17 for 90 minutes in July 1943. Within that time, I understood that we were facing an enemy with industrial resources we couldn't match. I wrote a report saying exactly that. The report was filed. Nothing changed. For the next 2 years, I watched my predictions come true." That's the tragedy. We saw what was coming, we documented it precisely, and we were powerless to change it. The story of Lerche's B-17 evaluation reveals something important about how wars are won and lost. Technical excellence matters, tactical skill matters, but industrial capacity matters more. Germany built excellent aircraft, flown by brave pilots using sophisticated tactics. America built good aircraft in overwhelming numbers, flown by adequately trained pilots using doctrine that emphasized mutual support and attrition warfare. In a short conflict, German excellence might have prevailed. In a long war of attrition, American industrial might proved decisive. The B-17 Flying Fortress was the physical embodiment of that advantage. It wasn't the best bomber ever designed. It wasn't invulnerable. It wasn't perfect. But it was good enough. produced in numbers large enough and supported by resources deep enough to overwhelm German defenses through sheer persistence. The question posed by Lerche's test flight was whether defensive armament could make fighter escorts obsolete. The answer was nuanced. The B-17's 1350 caliber machine guns made it far more survivable than previous bombers. Flying in tight formation with overlapping defensive fire, B-17 groups could inflict heavy casualties on attacking fighters. For missions over France and the Low Countries, relatively close to England, B-17s could operate with minimal fighter escort and accept the resulting losses, but for deep penetration raids into Germany against concentrated Luftwaffe defenses, bomber losses without fighter escort proved unsustainable. The raids on Schweinfurt, Regensburg, and other deep targets in 1943 demonstrated this clearly. Defensive armament helped, but it wasn't sufficient by itself. The bombers needed escorts. When those escorts arrived in the form of P-51 Mustangs in early 1944, the combination proved devastating. Heavily armed bombers protected by long-range fighters created a system where German fighters faced impossible choices: attack the bombers and face mass defensive fire, engage the escorts and allow bombers to reach their targets unmolested. Either way, Germany lost. So, Lerche's conclusion from his 60-minute test flight was both right and wrong. The B-17's defensive armament didn't make escorts obsolete, but it reduced the escort requirement enough that American bomber doctrine remained viable even during the difficult months of 1943, when escorts couldn't reach deep into Germany. And when escorts arrived, the defensive armament multiplied their effectiveness by forcing German fighters to divide their attention. In the end, the B-17 Flying Fortress achieved its strategic purpose. It carried the bombing campaign to Germany's industrial heartland. It destroyed factories, refineries, and transportation networks. It forced Germany to divert massive resources to air defense, resources desperately needed on other fronts. And it did all of this while suffering significant but sustainable losses that America could replace while Germany could not. Hans-Werner Lerche understood this after 60 minutes in the air over Germany in July 1943. He wrote it clearly in his report. The report was filed and forgotten, but history proved him right. The question wasn't whether German pilots were brave enough or skilled enough to defeat American bombers. They were both. The question was whether Germany could sustain the attrition necessary to stop the bombing campaign, and the answer, written in the mathematics of production capacity and resource availability, was no. Today, fewer than a dozen B-17s remain airworthy, maintained by museums and preservation groups. They fly at air shows carrying passengers who want to experience what it was like to fly in a World War II bomber. When you see a B-17 in flight, the first thing you notice is the sound. 4 radial engines create a distinctive rumble, deep and powerful. The second thing you notice is the size. It's massive, far larger than photographs suggest. But if you're allowed inside, the third thing you notice is the guns. They're everywhere. Looking around the interior, you see gun positions at every angle covering every approach. Standing in the fuselage, you begin to understand what Lerche understood during his test flight. This wasn't just a bomber. This was a weapons platform designed to fight its way to the target and back. The Americans had taken the traditional concept of a defenseless bomber and reimagined it as something far more dangerous, a bomber that could defend itself, not perfectly, not without losses, but effectively enough to sustain a strategic bombing campaign against the most heavily defended airspace in the world. That achievement, more than any individual technical specification, is what made the B-17 Flying Fortress historically significant. It proved that with sufficient defensive armament, proper tactics, and overwhelming production, heavy bombers could operate in contested airspace and achieve strategic objectives despite fierce opposition. Lerche's 60-minute flight revealed this truth. His report documented it, and for the next 2 years, the skies over Germany proved him right with mathematical precision. The era of the defenseless bomber was over. The era of the self-defending heavy bomber had begun, and when fighter escorts joined them, the combination became the decisive weapon in the air war over Europe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.